when we met on Monday. But it's like a logic tree. All matter is made up of atoms, and all atoms weigh something, and all atoms will occupy a certain amount of volume or space. And then matter then can be, we kind of do this sort of logic thing. So is the matter pure or is the matter a mixture? Okay. And I've got actually some examples in blue up here. We're going to kind of go around the room. So what do you think the matter is? If it's a pure substance, it can either be all the atoms are the same, and it's an element, or we'll be talking more about compounds. We can take atoms of different elements. I'm going to pull up my periodic table. So we don't have one in the room right now. You can take atoms of different elements, stick them together in a repeating unit, and you can get a compound. You're all kind of familiar with this. You guys told me NaCl was salt. You told me water is H2O. Okay, so that would be an example of a compound. You can take elements and or compounds, physically toss them together and get a mixture. Okay? Now, if your mixture is like homogenized, like homogeneous milk, okay, if it's the same throughout, we'll call that a homogeneous mixture. I call this one chunky. If it's heterogeneous, okay, if it's chunky, then we call it heterogeneous mixture. So let's see what we think. And we'll start over here with you.
Did you about to say Narnia?
Yeah. No, I was going to say Narnia. No. I'm sorry. Okay, no. So what about hard-boiled egg? Which, your choices are down here at the bottom. Element, compound, homogeneous. What, do you think it's an element? Do you think it's a compound? I'm going to tell you it's not a compound.
Oh, no.
Okay, so what do you think if it's a hard-boiled egg, if it's a mixture? Because to me, it's like you can see the shell part, you can see the white part, you can see the yellow part. I know, because you make wonderful salads. Do you help make those salads sometimes?
I don't like hard-boiled eggs, so
Okay. Hard-boiled egg has those three parts. Now, are those three parts well mixed, or is it chunky? It is chunky. Yeah, exactly. Because depending on if you're the outside of the egg, you're the shell. If you're in the middle, you're the white part. If you're in the center, you're the yolk, you're the middle part. So it's heterogeneous mixture. Good job. Okay, Mackenzie. Table salt. So here are your four choices: element, compound, homogeneous mixture, heterogeneous mixture. It is a compound. It's NaCl. That's the repeating unit. Very good. So Hannah, what if we take salt, table salt, and physically put it in water? So now we have a cup of salt water. It is. She went right to it. She said it's a mixture and it's the same throughout. It's a homogeneous mixture. Perfect. We still have sodium chloride and H2O. Perfect. See, Kate, all the names this morning. Okay, a piece of pepperoni pizza. Is it an element, a compound, a homogeneous mixture, or a heterogeneous mixture? It is heterogeneous mixture. Yeah, it's kind of back to the egg thing. Exactly. How could we take a piece of pepperoni pizza and homogenize it? Put it in a blender. Oh. Desperate times, I guess, if you're drinking through a straw, right? Okay, Ashley, we'll go back to you. What about, now not your whole ring, but just a diamond, a stone, a diamond in your ring? Do you think this might be a hard one, do you think that's an element, a compound, a homogeneous mixture, or a heterogeneous mixture? It's like on a game show. Just a diamond. I'll give you a hint. Because we haven't talked much about this, but diamonds are amazing. If you find carbon on the periodic table, diamonds are just made of that. And so is actually those of us who are using pencils. You're using the pencil, we call it lead. It's actually just carbon graphite. So that's a different form of carbon. So what do you think? Element, compound, homogeneous mixture, heterogeneous mixture? Okay, Ian. Oh, okay. Stainless steel. Are you familiar with I'm not real familiar with it, but there are different grades of stainless steel. And I don't know a whole bunch about it, but with that in mind, different grades, do you think that it's an element or a compound homogeneous mixture or tricky heterogeneous? That I can see compound. Yeah, I can go with that. Very good. Okay. Done. You used to do it for the subject. So not. Okay. What about air? Is it first off? Did we talk about air yet? We didn't talk about air, but we're breathing it in. And so, do you think it's all the same thing? We're breathing in all the gases. I don't either. So, element, compound, homogeneous mixture, heterogeneous mixture. I can see either case. Why did you say hetero?
Because it's different mixtures.
Different mixtures at different locations. I can see that. I could go either one. Very good. All right. I actually have a few videos I want to play for you. So here's another periodic table. Now notice that this, how can you tell me or whatever that this periodic table is older than the one that I gave you? Doesn't have these guys filled in. And it's just how exciting to be that nerd of a scientist who finally makes those atoms exist long enough to be elevated to make it to the periodic table. Yep, so these aren't filled in. I do like it though. I like the one I gave you, and I like this one because it's color coded. And I'll be asking some questions about kind of the color codedness. Okay. So 118 confirmed elements, 98 naturally occurring ones. Okay. Under normal pressures and temperatures of the atmosphere, there are 2 liquids, 11 gases, and everything else is the solid. Let's see, the liquids are blue. Can you find the 2 liquids? And what elements are they? What's that? Br, very good. Br, bromine, that's a liquid. And mercury, Hg, yep, those 2 are liquids. Okay, the gases are in red. Let's see if we can come up with what's my slides say 11 gases. There's nitrogen. What else? Hydrogen, helium, makes me laugh, and oxygen, fluorine, neon, chlorine, and all these guys, right? Argon, krypton, xenon, radon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks good. Okay. So an important thing about our periodic table, and one of the things about the ones I gave you, if you have a pen or whatever, and I know you may not want to mess it up, but it really should have what I call the jag. And you can see the jag here. The jag goes between aluminum, is that right? Yeah. Aluminum down on top of germanium down, on top of antimony down, on top of polonium down. Okay, that jag is important, and it's not very obvious here. You can barely see it with maybe the colors, but they made them kind of both green. So I would kind of pencil that jag. What's so important about that jag is it separates, and I'll go ahead and draw it on here. I'll be talking about what you can bring to your chemistry test. If you want to take this, or if you want to do the periodic table, that's fine too. So it separates the metals. So these guys over on the left are all metals. And these guys, I kind of call it a triangle, kind of this right here. These guys are nonmetals. Yeah, and like I said, I will be getting you a different periodic table if you make this one too messy, you don't want to use it. Okay, so nonmetals and metals, and it's an important designation. So what do you think? Are there more metals or nonmetals? There's much more metals, yeah. So is oxygen a metal or a nonmetal? It's a nonmetal. Yep, very good. Oh yeah. So there was two videos on the slide, and I think this is the only two videos I picked out for today, but check this out. This is so funny. Little elements. Gotta love them. We just now, I had you we talked about the JAG, and not related to the JAG necessarily, is this idea of how the periodic table kind of got its layout. There's this person called Mendeleev. His last name is Mendeleev. He's Russian. And the folklore goes that in a dream, he actually kind of said, well, he basically, where's my periodic table? People had been kind of understanding elements and finding elements and isolating them. And so he kind of had these note cards. Each element was on a card. And he's like, well, you know, I think if I come up with what we call the modern day periodic table, it could kind of make sense with regard to being what we call periodic. I think a good way to describe periodic is like a month. Okay, it totally is. I'll put all these up here. So, for instance, if we were to look at, I'm not going to look at any month in particular, but just go ahead and start Sunday through Saturday, days of the week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And maybe your life's a little different than mine, but like I do kind of some very similar things on Sunday. I do some very similar things. I have similar emotions on Monday, Tuesday. So it kind of goes like this. So the first day this month could be 1, 2, 3, 4, 5, 6, 7. This would be the 8th day of this particular month. Then we start all over again. It goes here 9, 10, 11, 12, 13, 14. All right, did I have two things?
You have 2 Sundays.
Oh my gosh, that's not, thank you. I was getting too many things in the week. That's better. Thanks. 8, 9, 10, 11, 12, better. 14. Okay. So this is my mythical month with 7 days. Okay. So these guys are all kind of similar. It's periodic. It repeats itself. And if we look at the periodic table, then the days of the week would be these guys right here. Okay. These guys have similar properties. These guys have similar properties. Okay. It's the periodicity of the elements. So cool. So I think I already used the word groups. So up and down is called a group. So these guys are in the same group, these guys are in the same group. And I apologize in advance, but there's actually 2 ways to name a group. And they're actually both up here and they're both down there. So for instance, are they both here? Oh no. That's one thing I didn't like about periodic table. Notice where it says 1A, 2A, and then go clear over here to boron. Above B or boron, I have 3A, 4A, 5A, 6A, 7A, and 8A. I think I probably would add that to my periodic table just because it's the old timey way. So above hydrogen, I'm going to put 1A. Above beryllium, Be, I'm going to put 2A. I'm going to skip over to boron, I'm going to put 3A. Carbon above that, 4A. 5A above nitrogen, 6A above oxygen, 7A above fluorine, and 8A above helium. And then I'm not gonna take the time because it just annoys me. I'm just gonna put B's right here for these guys, beginning with SC and ZN. Okay, scandium, I think, I know, and zinc. Those guys are all B guys. These guys are B guys. So I'm gonna kind of do I did like a, so what I started to say is they each have kind of 2 names. The groups, like hydrogen would be group 1 and it will also be 1A. But if we skip over here to nitrogen, okay, what's its group? What's its group numbers? Nitrogen, phosphorus, arsenic, antimony, and bismuth. Or that's not bismuth, that's something else. Yeah, it's bismuth. What's that? They're 5A and they're also 15. So that's both those, 5A and 15. So here actually it just says, here it just says 15. So 15 is kind of newer to 5A for kind of old timey, but I think there's still validity in both. So you're gonna, this video, or not video, but all this does is kind of show you the groups. So up and down the groups. They're a day, a week. Sometimes groups are called families. I'll put that up there too, just for kicks. I can find my stylus. Groups equals families. We are family. Okay. So now going across would be like a given week. And going across is not a group, it's called a period. So this kind of shows you the periods. Now one of the things I don't like about this, but I do like about the periodic table I gave you, is it has the period over here. So this 1 through 7, those are the periods. So what period is argon in AR? Yep, it's in 3. Perfect. What period is silver in? Silver is AG. It's period 5, exactly. So like I said, I think what this is missing is it should have 1, 2, 3, 4, 5, 6, 7. So I kind of mentioned these guys down here, which are missing on the slide. They talk about when we found these elements out to 118, that finished period 7. So you see where we get that from? Finished period 7. Finish the week. Let's see, what else do you need to know? Know the names of these groups. So that's why I had you put the 1A, 2A, 7A, and 8A. Actually, if we kind of look at the color codes, okay, the color I gave you, actually 1A is this orange color. That is, those are the alkali metals. The yellow are alkaline earth metals. So we have 1A, 2A, alkaline metals, alkaline earth metals. So I guess you might want to put a little star or something. You could put a little star next to that orange and the yellow. I'm not telling you how to study, but know those. And then the other, I said 7A and 8A. Let's see. Oh, 7A. Yeah. So 7A, see how it says the name halogens up there? So know the word halogens. Right above fluorine, it says halogens. So halogen is the word I'm after there. And 8A, I'm after noble gases. So you probably want to kind of denote those. Noble gases are 8A. Any questions? They're special. They're classics. So Shipman looks at it a little differently, which is fine. He calls the green ones listed here as representative elements. Now, to me, what I call representative elements are the main group elements, sometimes called the group GP for group A. Do you see why I would do that? The group A elements. I had you put 1A, 2A, 3A, 4A, 8A. Okay, they're the representative elements. And I guess they're called main group elements because when we kind of start to study trends in elements, they follow the trends better than the other guys. So if those are representative elements, then the other guys are the transition elements. Okay? So these B ones are transition elements. sometimes called Group B. Go figure. Is that all I had on that side? Or is my build stopped? Probably. Okay. So which particle is the outermost particle of an atom? Is it the proton, neutron, electron? It is the electron. Yep. And as it turns out, and I think, I got ahead of myself. That's next thing. When we say atomic number, I'm switching gear. You told me electron is the outermost. When we say atomic number, what are we talking about there? Which particle? Yep. Atomic number is the number of protons. Now, in my other class that I teach, one of my other intro chemistry classes I teach, actually they don't get this right. They can't bring their own periodic table. I'll give them a periodic table, but they won't have the names. Like C is for carbon. And actually, what this slide says is for that group anyway, I make them memorize C is for carbon, or carbon is the symbol for carbon is C. And I have them do this by atomic number. So which element is atomic number 50? It is tin, yep. And so you see in that case, and you guys will be fine, because I'm not being as hardcore with you guys. But for them, they have to recognize that Sn is tin and tin is Sn. So I think when we, Friday, when we come, I'm going to start out and show you this cool little app. It's a game that kind of helps you learn the names of the elements. Now, I kind of got ahead of myself. This is what I meant about the electrons. So if we have this whole same sort of feeling going on with elements in the same group or the family, what gives them that familiarity is how the electrons are hanging out. Do you remember the other day when we talked about the structure of an atom, we said that with Bohr's atom and Schrodinger's model of the atom, we said that the electrons in a cloud outside the nucleus, they actually are different energy levels, discrete energy levels, what we call quantized. So that's actually what makes them similar. When I say them, I mean elements in the same group. Okay. I'm so confused with my slides. That's okay. Oh, it's coming up. So electrons, let's pick on carbon. Now, if carbon is a neutral atom, how many protons does it have? Well, if it's neutral, how many protons does carbon atom have? It has 6. Yep. So let's make our cute little carbon atom over here. Seems like this is that kind of gets lost in the shuffle there. Carbon. So it's got 6 protons. I'll make protons pluses. And not always, but a lot of times it'll have the same number of neutrons. So I'll make neutrons zeros. 4, 5, 6. Okay, so that's the nucleus of my carbon atom. If it's neutral, how many electrons does it have? 6. It has 6. Yep. Okay. So, and as it turns out, I'm going to go ahead and use kind of these shell things to show you that those 6 electrons are at different energy levels. And we're not going to get into this too much in this class, but this is really kind of how it works. So the first 2 electrons are going to be here. Oh, and the next 4 electrons are going to be actually, they're all in the same principal energy level, n is equal to 1. So here we go. They're kind of close together. So 6. So what's underneath carbon with regard to being in the same family? Silicon? Oh, okay. So silicon, so how many protons are in a silicon nucleus? 13. I'm just going to put 13 protons. That's okay. It's 14. 14. Oh, thank you. Thanks. Like there's 2 Saturdays. Did I try to make 2 Saturdays in a week? Or did I just try to make 2 Sundays in a week? Okay, so 14 protons, so how many electrons? It's also going to be 14. Now, this is a case where in n is equal to 1, actually we end up with, as it turns out, 8 electrons. Okay. So, if I have 8 there, how many do I have in n is equal to 2? They add up to 8, they add up to 14. So I end up with 6 out here. Okay. I'm totally butchering this, but it's true. 6 electrons. That's what makes them simpler. That's what makes them, these are what we call outer electrons, and then what we call valence electrons. And that's what this thing shows you. So we picked on these guys right here. Okay. See, I did do that. That's the 2. Even. Start with this one. I only have, okay. Because when I'm looking at this, this is reminding me that there's actually should have been 2. How does that work? So there's 2. And 6, there's 8. Oxygen.
You did carbon, that's why. You did carbon.
I did.
Not oxygen.
Okay, thanks. Okay. Okay, I will fix this. I know you're like, seriously? Oh my gosh, I hate when I do that. I was winging it. Start with this. So, but good luck preparing for your test. I'm going to ask any questions, and I'll be here. Your test is at 10. I'm usually here by at least by 9. So if you have last minute questions, let me know.
That is what I switched it to oxygen from. I don't know. We'll get it.